Hello friends, and welcome to another lecture on chemical engineering thermodynamics. Today we'll take a problem from Chemical Engineering Thermodynamics 1 paper of Mumbai University. This problem had come on December 17 and the question is 5B. The question is on your screen and we have this question for 10 marks. So it's a very simple question for which 10 marks is rather over justified, but still let's solve the problem and let's see that how it can be solved and you can get simple answers for it within no time or short time, right? Now it says that a lump of steel of mass 10 kg at 600 degrees Celsius is dropped in 100 kg oil at 35 degrees Celsius. The specific heats are given to you. Calculate the entropy change of steel, oil and universe. Now as usual I would explain the problem and solve it, but you can solve it quickly. Now this is the oil, of course this is the steel ball or steel mass. Now when the steel mass is put in the oil, we treat this entire oil plus steel mass as our system. The moment it is put, we treat it as a system. Now the steel mass initially was at 630 degrees Celsius and the oil was at 35 degrees Celsius. Now if we take the oil plus the steel mass as our system, for this writing the first law is going to give you delta U is equal to Q plus W. Now neither heat has been added to the system, neither work has been added to the system, so this is 0. So the change in internal energy of the system is 0. Therefore we can write the change in internal energy of the steel mass plus the change in internal energy of the oil is equal to 0. Now for this we can say mass of the steel into specific heat of the steel into its final temperature minus the initial temperature of 630 degrees Celsius plus mass of oil into specific heat of oil into its final temperature minus its initial temperature of 35 degrees Celsius is equal to 0, right? Now these are the changes in internal energy, where the change in internal energy always for any fluid is its mass into its specific heat at constant volume into change in temperature. Now for a solid, Cp is equal to Cv is equal to C, that is specific heat at constant pressure is equal to specific heat at constant volume and is equal to C. So we use that idea and we write this. Therefore we get the equation 10 kg into 3.5, not 3.5, 0.5, steel is 0.5, 0.5 into Tf minus 630 plus this is 100 kg of oil into 3.5 into Tf minus 35 is equal to 0. Now let's go on with the calculation and let's calculate the final temperature. So for this we can write it as 10 into 0.5 into, start the bracket, alpha x minus 630 plus 100 into 3.5 into alpha x minus 35. alpha is equal to 0, and shift solve and we get our answer. So that's 43. So the final temperature is 43. So T final, that is the final temperature of the steel mass and the oil, is going to be 43. Let's note down the decimals if we really need a better calculation. 43.38 degrees Celsius. Now, for this system, if we have to write the entropy equation is going to be ds by dt is equal to summation of the mass flowing in and out of the system into the entropy of the streams flowing in and out plus summation of q dot by T, that is the heat given to the system, divided by the temperature at which the heat is given or received, plus S dot generated, that is the entropy generated. Now here there is no stream flowing in and out, so this is 0. And externally we are not supplying any heat, so this is also 0, right? So what we have now is ds is equal to S dot generated into dt, or the change in entropy of the system is equal to the entropy generated, right? Now what is the change in entropy of the system? The change in entropy of the system is going to be the change in entropy of the steel mass plus change in entropy of the oil. That's going to be the change in entropy of the system. Therefore, entropy we define as ds is equal to dq by T, which is nothing but mass into C into dt over T. So change in entropy is nothing but mass into C into ln of T final by T initial. So the change in entropy of the oil, of the steel mass, let's take the steel mass first, is going to be equal to 10 kgs into 0.5 into ln. Now we have to take care that we have to take the temperatures in Kelvin. So the final temperature is going to be 273.15 plus 43.38, and the initial temperature is going to be 273.15 plus 630, right? So the change in entropy of the steel mass will be 10 into zero point 0.5 into ln 273.15 plus 43.38 divided by 273.15 plus 630, and that's minus 5.2423, that is minus 5.2423 kilojoules per Kelvin. Okay. Now change in entropy of the oil is going to be 100 into 3.5 into ln of 273.15 plus 43.38 divided by 273.15 plus 35. So change in entropy of the oil is now going to be equal to 100 into 3.5 into ln of 273.15 plus 43.38 divided by 273.15 plus 35, and that will be 9.391. 9.3909 if we take it to 4 decimal places, and we will write it as kilojoule per Kelvin, right? So finally we have both the answers, that is answer number 2, answer number 1, that is change in entropy of the steel ball, change in entropy of the oil, and change in entropy of the steel mass plus change in entropy of the oil is going to be equal to minus 5.2423 plus 9.3909, and that's going to be equal to the change in entropy is now going to be equal to the overall change in entropy of the system. This is going to be overall change in entropy of the system, as we have shown here, is going to be equal to minus 5.2423 plus 9.3909, and that's going to be equal to 4.1486 kilojoules per Kelvin. That is going to be your change in entropy of the system. Now, this has not been asked, but let's try finding out what is the change in entropy of the universe. This may be asked in some question paper. So that we should be aware how we should solve it. So that's going to be change in entropy of the system plus change in entropy of the surroundings. Now, since no heat was given or taken from the surrounding, the change in entropy of the surrounding is 0. And change in entropy of the system is 4.1486. So, change in entropy of the universe is 4.1486 kilojoules per kg. Kilojoules per Kelvin, not kg, Kelvin. So, that's it. That's going to be your change in entropy of the universe, right? So as you can see, for any process, the change in entropy of the universe is always positive. So that was all, friends. Do subscribe my channel. Your subscription is a great motivation to me to produce such videos which are going to help you, at least the students and the teachers, which are going to help you in your teaching, in your learning. So keep watching videos, and yes, popularize these videos, and see to it that whomsoever you popularize, whomsoever you send, they subscribe my channel. That's very important. Okay, friends, goodbye.